Hello, good evening. This video series I have started for the explanation of mathematics course for the grade 9 class. In this video lecture series, I am going to explain all the topics step by step and all the examples as well as the questions which I have already solved and I have already written on the PDF file, but here I'll explain everything in this video series about the whatever the requirement. So I'll explain all the mathematical rules in these video series. Now today the topic is algebraic fractions. In the previous classes, I mean grade 7 or 6, we have already discussed about the algebraic fractions in numbers. For example, 6 divided by 4, for example, 10 divided by 11. So these are called algebraic fractions that were in numbers. But here we are dealing with algebraic fractions in variables. In these topics, the algebraic fractions or is the quotient of two algebraic expressions. It means that this terminology shows that the algebraic expression algebraic fraction means that we have one algebraic expression in the numerator and the second algebraic expression in the denominator. And one question arises that first of all, before going to explain the algebraic fractions, let me talk about algebraic expressions. Every polynomial, even I can say with every numbers there is a variable and the power of variable is 0. For example, I'm just writing 2. So 2 is a number with which there is variable but we cannot write them because the power of variable is 0 and the power of variable is 0 means that it is equal to 1. So 2 multiplied by 1 it means 2. So it means that with every numbers we can write x power 0 that is equal to 1. So when 1 is multiplied with any number, again the result is that number. So every number we can say that that is algebraic expression. And secondly, in algebraic expression, it is not confined that the power of variable should be whole number, as we already know about in polynomial that the power of variable in polynomial must be a whole number. There are few possibilities that in algebraic expression the power there might be coefficient. Coefficient may be any number, may be positive, may be negative. There must be variable and there must be power. So now the question arises that in algebraic expression it is not confined that the power of variable must be a whole number, because in polynomial we can say that the power of variable must be a whole number, but in algebraic expression the power may be positive, may be negative, may be fraction, may be in decimal form. So we can have these possibility that in algebraic expression the power may be written in positive, may be negative, I mean to say positive number, negative number, fraction and decimal form. So now the question arises that what is the difference between algebraic expression and polynomial. In polynomial it is very important to note that point that in polynomial the power of variable should neither be negative nor fraction nor in decimal form. It must always be a whole number. So now the question arises that whether we can say that every algebraic expression is a polynomial. No, we cannot say. But we can say that every polynomial is algebraic expression, but every algebraic expression may or may not be polynomial, because if in the algebraic expression the power of variable is positive, negative, fraction, or in decimal form. So all these four categories we can say that they are algebraic expression. But only one category we can have in this out of these four, that is only polynomial when the power of variable is only and only whole number, and whole number we already know that is started from 0, 1, 2, 3 in the positive direction. Now in algebraic fraction, the we have two polynomials, we have two algebraic expression. One is in the numerator and the second one is the denominator. So when they both are written in the form of quotient, then we can say that they are called algebraic fraction. Example: x minus y divided by y square minus 4x square. In the numerator we can have x minus y, that is one algebraic expression, but in denominator we are having another algebraic expression. When they both are, since they both are written in the quotient form, so they are called algebraic fraction. Example number 2, as it is written, that simplify x plus y divided by 3x plus 2y and plus x minus y divided by 3x plus 2y. Now here we have two algebraic fraction, and one is on the left side and one is on the right side. In between them there are four possibilities. If in between two algebraic fraction the sign and operation, we also can say operation, is positive and negative, then we have the rule of LCM to be adopted in order to solve this question. But if we have multiplication in between these two algebraic fraction, then there are two possibilities, because you have four algebraic expression, two on the left side and two on the right side of the multiplication. So if there is possibility of crossing, so you can cross them. But if there is no possibility of crossing means, just imagine that the factor available on the top, the same factor available in the bottom, so you can cross them. But if there is no possibility of crossing any factor in the numerator and denominator, then the only way by which you can solve this algebraic expression, algebraic fraction, that is multiplication, and multiply the numerator with numerator and denominator with denominator. After multiplication, sometime we also have the possibility of crossing. But if there is no possibility of crossing any similar factor, then leave the question in that point, because that is the complete answer. The other thing, because we have another possibility as well, that x plus y divided by 3x plus 2y, that is one algebraic fraction, and right side we have another algebraic fraction. If in between them there is a division operation, then we have possibility, then what method should be adopted in order to solve this question? So then the possibility that the left side algebraic fraction should be written as it is, but the right side should be written in a reciprocal form, and the division will be converted into multiplication. Again I am repeating that in between two algebraic fraction, if there is a sign of division operation, then the method which you will have to adopt in order to solve this question is write the left side algebraic fraction same as it is, but convert the division operation into multiplication and write the right side algebraic fraction in a reciprocal form. It means, what does reciprocal mean? In reciprocal means that your numerator will become denominator and your denominator will become numerator. So it will be in a reciprocal form. Then it means that you have converted a question from division into multiplication form. Then follow the multiplication rule, which I already explained before. That if there is possibility of crossing of same factor in the numerator and denominator, then cross them. If there is no possibility, then multiply the numerator with numerator and denominator with denominator. Now we are coming to solve this question, so let's come to solution. As the question has been written again, now in between these two algebraic fraction we have the sign of plus. So when there is sign of plus and minus, the possibility of method which we have to adopt, take the LCM of denominator. Since in the denominator, since we know that LCM of any two or more than two polynomial, whenever we will have to convert all the polynomial in a factor form, because these two denominator 3x plus 2y and 3x plus 2y, they both have been written in a factorized form. There is no anything which should be taken as a common. So LCM is, by its mathematical formula, LCM is equal to common factor multiplied by non-common factor of all the polynomials. Since in this question we have only two polynomial in the denominator, left side is 3x plus 2y and the right side is again 3x plus 2y. Since both of them are same, their operation plus and their terms also, totally we can say that they are same. So when we have to take the LCM of these two, just take the common factor. So since both of them are same, so only one common factor should be taken, 3x plus 2y. Then draw a line on the top of the 3x plus 2y. Now the LCM has been taken as 3x plus 2y. Take 3x plus 2y divided by the top 3x plus 2y, so result will become 1. Then multiply that result with the numerator x plus y, so it will become x plus y. Then in the middle in the question it is a plus sign, so write the plus sign. Again 3x plus 2y divided by 3x plus 2y, again the result is 1, so multiply that result with x minus 1, so the result will come x minus 1. Now in the numerator we have x plus y plus x minus y. In these four terms there are two terms in which signs are different. One is plus y, one is minus y, so both of them will cancel, so x plus x will become 2x divided by 3x plus 2y. This was the solution of this example. Now I am coming to another example. X minus y divided by x plus y, then minus x square minus 2y square, denominator x square minus y square. Now we have to solve this question. First of all, we have to think about it, that how many algebraic fraction are given in this question. So we can see that only two algebraic fraction are given in this question. One is on the left side of the minus and one is on the right side of the minus. In between them the operation minus has been put, so it means that we have to follow the method of LCM. LCM are not taken of numerator. LCM are always taken of numerator in denominator. In denominator we have two polynomials. One is x plus y, which is a simplified form. I mean to say that which is a factor which cannot be further reduced. But in the other side we have x square minus y square. We have one formula that x square minus y square, that is a quadratic factor, and we can convert it into linear factor, that will be x plus y into x minus y. But whenever we have to take the LCM of these two polynomial, so as I already explained that in LCM we have to take the common factor multiply by non-common factor. So if we convert x square minus y square into its linear factor form, that is x plus y and x minus y, so the common factor in between these two polynomial is x plus y, and the non-common factor is x minus y. Whenever both of them are multiplied, so the result will become x square minus y square. It means we can say that the LCM of these two polynomial is x square minus y square. So we can write them in x square minus y square form as well as x plus y into x minus y. Now the process we will have to follow, because the LCM we have already found that x plus y and x minus y. Now LCM divided by the denominator of the first algebraic expression, that is x plus y. So x plus y will be cancelled. The result will be x minus y. Now multiply x minus y with the top x minus y. So two same factor will come. We can also write them x minus y whole square. Then in the middle it is written minus. So one thing I want to clear in this point, whenever a minus is coming you must write a small bracket, because minus change all the signs of the remaining terms. If there is plus, no matter, no need to write any small bracket, but whenever minus is coming, small bracket must be put there, because minus change all the sign of the remaining terms. Second thing, x plus y, x minus y, that is LCM. So LCM divided by the denominator of the second algebraic expression, that is again x plus y, x minus y, so result will become 1. So 1 will be multiplied with the numerator of the second algebraic fraction, that is x square minus 2y square. So when something is multiplied with 1, the result will again become something. So you can put it here, minus x square, now plus 2y square. The question arises that in the numerator it is written minus 2y square, but here it has been written plus 2y square. What is the reason behind it? The reason behind it is that because minus change all the sign of the remaining terms. So it was plus x square, here it is written minus x square. In the top it was minus 2y square, but here it is written plus 2y square, because minus change all the sign of the remaining terms. Now we are coming to the next point. X minus y square, we already know this formula. First x square plus y square minus 2xy, then minus x square plus 2y square. Now we have these 5 terms in the numerator. So let's see which one is possible to be cancelled. One is plus x square and the second one is minus x square. So these two will be cancelled. Then the remaining are not possible to be cancelled. They should be kept as it is. So in the final we will have answer, because one is 2y square plus 1y square, that will become 3y square, and the remaining term is minus 2xy divided by x square minus y square. You can also write them x plus y, x minus y. No one can say that this answer is wrong. If you will write x plus y, x minus y in the numerator, so your question is again right. So this was the solution of the second example. So that's all for today. We explained the algebraic expression, algebraic fractions. Let me briefly explain again. In algebraic fraction, we have one algebraic expression in the numerator and the second in denominator. Whenever in between them there is a sign of plus and minus, so LCM should be taken, and stepwise they can be solved to the end of the solution. So this was some explanation about the algebraic expression solution. Thank you so much.